Hello, and thank you all for coming today. 3 days before Christmas Eve, 4 days before Christmas. I hope you will enjoy what I have to share with you today about FileCatalyst and live sports production. So a couple of housekeeping rules. If you have a question, please use the GoToWebinar question interface, and I will get to those questions at the end of my presentation and at the end of my demo. But feel free to enter them, and I will once in a while take a look at the questions, and if there's something relevant during my demo, I will definitely try to answer it at the time when I'm speaking. So let's get started here. So my name is John Tkaczewski. I'm the president and co-founder of FileCatalyst. We're a file transfer acceleration software company. We've been doing this since 2000. The company has existed actually since 2001, but the acceleration has been around since 2006. We work a lot with the media and entertainment companies, and we work a lot with sports broadcasters on different projects for transferring large files during live events. I also have a blog. If you go to filecatalyst.com, I think it's /blog, you can read a lot of articles that I've posted and my staff about file transfer security and media files and so on. So it's a good resource for you to gain some new knowledge. We've been, as I mentioned, we've been in this space since for quite some time. We did win 2 Emmys already for what we do. One Emmy is for accelerated file movement, and the other one was actually for Olympic Winter Games in Sochi in 2014 that we won for helping NBC Sports with the live production of Winter Olympics. So what we'll be talking today about, we'll talk about some challenges in live sports production. I'll give you an introduction into our accelerated file transfer suite. I will show you a bit about our solution and the demo, and I'll mention some of the specific features that we have for live sports production that we've built into our software over the years. So some of the problems, we've done several large events from Winter Olympics, Summer Olympics, Super Bowl. We've done a number of car racing, Premier Soccer, or football if you're in Europe. We've done tennis events. We've done also women's World Cup in Vancouver a couple of years ago. So here's some of the stuff we've learned. So first of all, files are very large. Whatever we do with live events creates very, very large files, and you need an efficient and reliable tool to move these files. Second of all, there is a geographical distance problem. So the events are all over the world. In car racing, could be almost on any continent. For football, it could be anywhere within USA. So we're dealing with large distances. We're dealing also with many different MXF formats. I will get into that in a minute, what we've learned over the years, but the growing, especially the concept of a growing MXF file is very misleading in the industry, and this is something that I wanted to talk about. The another thing, especially if you're going with very large events, you're going to have a lot of camera feeds, a lot of content, so you're going to have a very big concurrency where you're moving literally hundreds or even sometimes thousands of files at the same time back to your studio to get things done. And then there's the dynamic files, which I will talk in a minute. So first of all, MXF issues that we've seen is that MXF doesn't always grow the same way from one client to another, from one event to another. Some MXF files tend to grow at the tail end, so just something gets appended at the end and that's it. That's the simplest one. Some MXF files will accommodate the entire full space of the file and then start filling in the blanks of the file. So it's like almost like you're not doing tail end, but you're kind of, you build the pot first and then you fill the water in it. Another problem is the headers. Some headers grow, some MXF files require the header update, some don't. So this is something that we've also had to incorporate into our software to accommodate the synchronization of MXF headers as the file changes. Once again, there could be multiple camera feeds. So you have to, we have to be cognizant that we have to send many of these growing files at the same time. And some of them could be low res, but also some of them could be high res. Low res files have their own problem, is that they are growing very slowly. So if we transfer them too fast and we don't wait for a few seconds before checking if the file has grown, well, then we would finish the file transfer and none of the growing file infrastructure that we've built would ever work. So remember, keep in mind that the files grow differently. Sometimes headers need to be updated, sometimes they don't. Keep in mind as well that some files, there could be a lot of growing files at the same time coming at us at a file transfer solution. And keep in mind that low res are growing very slow, so usually they're growing slower than what your network can do. As I mentioned, there's two solutions for the MXF headers. This is probably one of the biggest headaches for a lot of vendors out there, is that a lot of solutions, video editing solutions, require the headers to be up to date before you can actually edit a file. So the way we do this is that we will wait until file is completely written to the disk and then provide a header update at the end. Or we can do a progressive update of the headers. So every 60 seconds we will re-update the headers of the file. Like this, you know, most remote editing software or video editing software will be able to pick that up and transfer and use it. So here's an example of our dynamic file support that we have in our software. I will go through these options in a minute. I just wanted to give you an example here of what it looks like. So this is on the growth and MXF and really more live event production oriented. Let's talk a little bit about transfer acceleration. So what's file transfer acceleration? Well, we can send any amount of data to anywhere in the world as long as we have an IP network. We're immune to latency and packet loss on the network by using UDP. So when we're transferring files, we're actually transferring all the data over UDP. And our algorithm, really, what makes us great is that we're very efficient at figuring out what errors are on the line and retransmitting the lost packets. So you're always guaranteed that you're going to get a perfect file intact, and you only will retransmit whatever data was lost. So this is not like a forward error correction type of technology where you always have to send extra data. Once again, UDP, the difference between UDP and TCP is that TCP, after sending a bit of data, has to wait for an acknowledgement, and then the next window of data is sent. So TCP is a linear process. As you're sending a bit of data, you're waiting. As you're sending more data, you're waiting. So you're spending a lot of time waiting and not sending. With UDP, we can continuously send that stream of data, and we can very quickly recognize what packets we're missing and retransmit those. So imagine we've built basically reliable TCP right at the application layer of the software. So this gives us the reliability, and it gives us also the ability to control the network. So when you're sending with UDP, there's also a misconception that it's not that hard. You can grab a file, start sending UDP. So there's one issue is ability to track the lost data. Second issue is the ability to slow down the transfer to allow other TCP background traffic to go through. So you don't want to get in a situation when you're uploading with UDP, all your other TCP connections stop working. So in our software, you actually have a lot of controls for that. You can specify how aggressive you want it to be towards TCP. Do you want to push it away but still let it through? Do you want to take up all your bandwidth? You can pick and choose this type of stuff in our software. So, but we do have something called an adaptive rate controller built in, which will speed up and slow down as the network conditions change. So with this no waiting, sending continuously, and not worrying about acknowledgements, what kind of speed improvements are we talking about? So the speed improvement really comes in when you have a faster network. So it's usually we require a network of at least 20 megabits to start seeing gains. And we're optimized up to 10 gigabits here. And this is an example of 10 gigabit networks. So you need a pipe. It has to be a fast pipe. It doesn't have to be super fast pipe, but of course like a regular plain DSL connection at 1.5 megabits, that's not going to work. It's not going to give you much improvement. But a 5, 10, 20 megabit connection, now you're going to start seeing an improvement. And you need a distance. So here's some examples. Amsterdam to London, it's 222 miles. FTP will take you an hour and a half. We'll do it in a minute 23 on a gigabit connection. As soon as this distance grows, LA to Mumbai, now we have 8,000 miles. FTP takes 3 hours. We're still a minute 23. So you can see it doesn't matter what example you give us, we'll be always minute 23 because we don't care about the delay on the network. And with packet loss, it's also a nice, very, very good protocol for networks where you have a lot of packet loss, for example, like satellite networks, where the speed degradation is linear with your packet loss. So a 10% packet loss means a 10% loss of your speed. It does with FTP, I think with 10% packet loss, we wouldn't even go through, but just gives you an example. And then with 10 gigabits, it's literally just this, but multiplied by 10 and divided by 10 rather to get a faster speed. And FTP, the speed is pretty much the same, slightly faster, I think, but not much. Depends. FTP will be a bit faster, but very little, because once you wait so long for these acknowledgements, there's no way you can fill a 10 gigabit pipe with FTP. With any TCP connection, I think we've seen maybe a gigabit at most, or 1.2 gigabits on a 10 gig line with TCP connections. With FileCatalyst, of course, you can get a full 10 gigs. So why is the accelerated, so why is our software a solution for all these things? So any kind of accelerated file transfer can give you the acceleration, but not every single file transfer solution out there will give you the ability to handle those growing files and ability to handle hundreds of growing files at the same time, and with the fine-grained control like I just explained here. So that's why this is where our software is a bit different from any other accelerated file transfer vendors, that we've built all these specific features for growing and managing headers, MXF headers properly, so you can actually do remote editing or creating remote highlights remotely instead of doing them at the venue. So here's some examples. So some of the key challenges in this space for transferring transferring files for live events. First of all, files are very big, so right away you need an accelerated transfer. There's a lot of distance, so that adds the delay to the network, as I mentioned before. Once again, this is where you need a file transfer that's immune to latency and packet loss, so you can send these large files. You have to handle multiple different MXF formats. Once again, depends on if you're using Avid or EVS or any other editing software out there. All of them have a little different requirements in order to be able to edit files remotely. We can handle most of these. There is an issue that you need to transfer a lot of files at the same time. So you're going to have your low-res proxies, you're going to have your high-res clips as well going in. You might have even some high-res proxies. So you have to have this extreme concurrency. I mean, at the Rio Olympics, at sometimes we were doing maybe 400 files at the same time to transfer, just to keep up with the load and keep all the editors happy between Rio and Stanford. Ability to send dynamic file sets, and this is the growing files that I mentioned, and handling the headers. So this is some of the checkboxes you need to consider when you're looking at live sport event production. A software solution has to give you a checkbox pretty much on all of these before you can consider it for a demo or to try it out. So here's an example of a standard, well, to be honest, nothing in the sports production industry is standard, but this is sort of an example of a workflow that happens for remote editing. So we have several MXF files being queued up on a file system. They come from cameras. We check if those files have not been transferred yet, and then we start transferring these files. And at the same time, we always scan the file system for any new files so we can add more files and transfer them. And this, here I have an illustration of 3, but we can do this, you know, for up to 300, 400 files we've done for larger events. So this gives you an idea of a workflow for this. There's another interesting thing that we could also handle low-risk proxies, which, you know, grow very slowly. And then the editor actually worked with the low-risk proxy to build highlights. And then there is a conform that can be sent, a conform file can be sent back to the venue server to create the high-risk clips of the seconds they want. Like this, you don't need a crazy amount of bandwidth between the venue and the studio because you're always sending on your low-risk files, and the high-risk clips are usually very short. There will be only a few seconds for your highlights to send back, and then you can do this with you can do with a fairly limited bandwidth. You can actually do remote editing of highlights. So we've worked a lot in the media and entertainment. Here's some of the sports clients we've dealt with. Let me just go back here. So, you know, we worked in tennis, we worked in motorsports, we worked in horse racing, we worked in soccer, we worked in football, Olympics, general Sky Sports. So anyways, just to give you an idea what we do and who we work with in this space. So once again, generally, if you have a sports, a live venue problem, we will have a solution somewhere in our portfolio of products. So let's go to the product demo. I'm always doing live demos at webinars. Always a little sometimes can backfire, but it's always good to show you what to expect and what we're looking at. So let's start with the basics here. First of all, we have a server. So this is your FileCatalyst server. This is a software application. There's no hardware required. You install it on, ideally in your studio, usually where it's connected to the storage, and then you have different users connecting here and dropping files to specific paths. Once again, these could be UNC paths. These could be paths as well to cloud. So if I want to create, for example, a home folder on my Amazon S3, I can drop files to the cloud with this software here. So this is really the server. This is really what sends and receives files. It doesn't have a lot of logic, but it has a lot of connectivity functionality. So you can create these users. You can create virtual folders. So you can have a different folder for each, let's say, event. And then when the user connects, they have access to only specific directories. You can group these folders into a group and then assign the group to a specific user so you can quickly create users. The server also acts as an FTP server and an SFTP server. So any legacy applications that still require FTP or SFTP can still connect to your server, but you can centrally manage where everything comes in and everything goes out. The server can also run through a reverse proxy if you're on a DMZ environment, and you can create that as well. This gives you the server literally has a lot of options here. You can send email links. I'm not going to go through all the options here because there's quite a few features you have that you'll probably be surprised from other solutions that similar solutions in the market. But this will give you an idea that you can create email links and send email links to files I'm sitting on a server, for example. So you have remote administration as well. So if you want to remotely connect to the server and check what's going on, this is all built in. So this is your server connectivity here. On the client side, so this will be more on the field. So imagine at the venue, you will have an application called Hot Folder. So the Hot Folder application is a client. It's a client application that connects to the server and can either upload or download files to the server. In this case here, I'm going to be doing demos of uploads. So the Hot Folder is going to be receiving new files from camera and sending those files as they're growing to the server. So there you can pick them up and use it in the studio. So the Hot Folder has, you can create multiple different locations or maps where to pick up files from. In this case here, I've created two. I really just need one for my demo I'll be doing. So I have here CA growing file demos. Once again, this can be UNC paths. So you can actually be checking on a network path. But this is usually where your low-res proxies or high-res files will be dropped into some folder at the venue, and Hot Folder will pick those up and send them to your studio. You can create a scheduler as well. You can also create a bandwidth scheduler, saying that during certain times you can speed up or slow down transfers. So this can be fairly automated and always on and transferring files as they're coming. Of course, for live sports production where you're doing real-time live highlights, then you probably want to have full bandwidth, but it really depends on this situation. And sometimes we set up two servers. One server deals with all the high-res content and one deals with the low-res proxies. It really depends what the workflow is, but we've done several, many of them since in the last I would say 3 years, and at this point I think we're not going to be surprised if you have something very specific to do. Some of the other stuff here in the reporting, you can of course you can enable reporting to see what you transferred from the Hot Folder. You have also reporting on a server, so you can see it as well there. So let's go to my demo of the growing files. So I have my folder here created, growing file demo. Here's my scheduler. So I'm just going to go through these options here. So this is very simple. I created a file called a growing file task. I've set it to be user triggered. It means I have to fire it manually, but I could automate it if I wanted to. But for the demo, I kept it manual. I can specify my congestion control and what to do. If this is highest priority, I'll bump up the priority. I can do verify if integrity at the end of the transfers, and I can enable multi-client. So this is what allows you to transfer several growing files all at once, and if a new growing file arrives, it will just get picked up with this option here, allow running task to be rescheduled with the file list inserted at the end of the queue. So imagine, if you will, we're dealing with 4 growing files. A 5th file comes, it's another camera feed, and all of a sudden you need this in the studio. Well, there's nothing to set up. Just point that camera feed to that folder that we're watching here, the growing file folder, and Hot Folder will take care of it. It will do it right away. So this allows you to create this, and you can specify how many you want. I mean, we've done up to 300 or so of these transfers at the same time, but in my demo here, I just want to keep it simple. Data minimization, once again, you don't have to worry about this tab, but you have ability here to do like an rsync type of transfers. And here's my dynamic files. So remember, I enabled here advanced progressive, so transfer any file and wait for 10 seconds to see how long to wait before we decide whether the file is finished or not. So if after 10 seconds it doesn't grow, we say it's finished and we mark it as done. Of course, if it increases again, then the task will pick it up later at the next round, but 10 seconds is usually. We've seen We've seen deployments where this had to be literally set to like 1 hour because MXF was growing so sporadically and sometimes wouldn't grow for an hour. So this is something that we've added. We can also do reverse. We can do a what do you call it? A reverse progressive. So that means that we're actually not going to be doing anything with the file until it finishes growing. That's another option that we have here. Retransfer headers and footers. So you can specify here after each growth operation, retransmit your header. You can specify your header bytes. So let's say you say the first 2 megs. We will retransfer those headers and footers to keep the video editing software on the other end happy, so it knows what to do with it. And then we can also retransfer with deltas. So we can actually do finally when we finish, we can do a delta of the file just in case if something changed on the header. That's another option. And here that we have. I'm going to file set and post tags will allow you to send emails to when the files are finished. Do a post URL and file set. You can say do this only for MXF files bigger than a gig, for example. So there's some options like that you have. So here's my task. So I don't have. This is a fairly simple setup here. I'm doing a webinar, so I really want to show you the growing file capability. So instead of a camera feed, what I have here is that my staff actually, we've built here a little testing app that allows us to create files, growing files at the speed we want. So here's my file. Here's the folder that I'm watching. That's the folder specified in hot folder. The file is 10 gigs, and I can specify to grow at 3000 kbps, which is 3 megabits. So it's going to grow at 3 megabits. It's an MXF file, and I'm going to fire it up here. So this starts generation of file. Here's my task. I'm going to now execute this task because now I have something going on. And I'm going to pull up the activity window. And you can see here now the first part, the first chunk of the file goes fast. And now you can see that the file is growing. Right here, see it's growing and it's always chasing that tail. And it's transferring that file. As the tail is growing, see it goes up a bit and then down to keep up with the lowest proxy that it's sending. And I'm transferring the file. So the rate is pretty fast still because at the beginning it started. So now the interesting part is going to be if I go to my MXF file here. Here's my second MXF file. And now I'm going to start generating a second MXF file at the same time in the same folder. This one I'm going to slow it down a bit. And now I started a second MXF file. If I go to my folder here, there's the second file. And in a minute, the hot folder will realize there's a second file and we'll start transferring it as well. Still not doing it. I think because that file is still 0. There we go. The file is growing now. And the file will start growing as the second file comes in. So you can see here that both files are going. For some reason, see this is, but it's not picking it up right now. But the worker, okay, so you can see here the file is growing and transferring through and it's going to always stay at 99% because of the speed that the file is growing. So really this is the entire demo of the transfer, of the file transfer, growing files. I explained them a bit more. I hope that now you have in detail, you understand in detail what we do. So that's it for my presentation. I will wait for a couple of minutes for questions. And if not, then we will wrap up.